Folks, when you try to figure where to start in this problem of the development of science, and to try to show what science is, it is difficult. There's so many things to try to bring in to a discussion of this type. So I talked to Dr. Cole a great deal about this, and my thought is that we would start with one of the very earliest of man's endeavors to try to acquire information. Now, we're still not sure whether this is what Stonehenge is, but when we talk about Stonehenge, it has to do with we think this, that it probably got started maybe about 3000 BC. Now, there's some question on that. But we do know that this is over in England, on the Salisbury Plain. It's over toward Wales. And this massive structure appears to have been started and developed over a period of possibly 1,000 years. Now, there have been people in England long before this. In fact, there is evidence that there were people migrating in from Spain as early as 18,000 BC, but we're not too sure. We feel sure that they did not start this particular structure called Stonehenge. But then in the neighborhood of about 3000 BC, a group of people migrated over from the main coast, main body of Europe, from Europe, and they're called the windmill people. How they got that name, we're not sure, unless that they migrated from the northern coast in what we now think of as Holland, where the windmill structures and so on have come into being. And then about 2000 BC, or 2500 BC, a group of people called the Beaker people, B-E-A-K-E-R, they migrated in. And the reason we call them the Beaker people is that they buried with their dead, they always put certain kinds of flasks of pottery, and they would put the people's belongings such as silver and precious things that those people wanted, and they would bury them with those people. So they were called the Beaker people. Now there's fair evidence. Now this is not 100%. But there's pretty fair evidence that these people started this structure called Stonehenge. And it's an amazing thing. Now, have any of you, in your travels, have any of you visited Stonehenge? If you're in England, you ought, by all means, to make it a point to spend some time at this mountain. It's one of the very largest of all the structures, really, in Europe. And the amazing thing, Jerry, would you want to put? Yeah. I don't have a rule or a pointer here. You know where I can use this. The structure. Oh, there we go. I can use this. And I notice, if you can see that, here are visitors to this monument, and it's a very large circular monument. And these stones right in here, notice now they're 20 to 30 feet high. And when you figure that they were made, this thing was made about in the neighborhood of 2000 BC, as best they can date it. These stones, called the sarsen stones, will weigh about 50 tons apiece. And the only place where you find this particular type of stone is about 130 miles away. And the question is, how did these people get these stones? How did they get them cut and then hauled to this particular place, this vast plain called the Salisbury Plain? And then, above all, how did they get them erected and get these flat pieces across the area here? Then it's a very orderly, now it's been damaged a great deal down through the years. Then there are other stones which are smaller, represented right in here. And these are called the blue stones. And that's because the stone is primarily a copper-bearing mineral stone. And some of these weigh as much as 50 tons apiece, and they had to be hauled down to this particular plane. Well, at first, as we tried to uncover the meaning of this, for a long, long time, the feeling was that this monument, maybe it was a sacrificial altar, because as those stones were laid out, there are a number of them that are just barely off the ground. And we've even come to call them the sacrificial stone. And for a long, long time, the theory was that they were used by the Druids. Now, the Druids came into England about 400 A.D. And they evolved into a culture which, well, you've all read of King Arthur, King Arthur's court. King Arthur, supposedly, and there's pretty fair evidence that he did live, and that he did have an advisor that we've come to call Merlin. And Merlin was a Druid. And they sacrificed, they made human sacrifices. And there's pretty good evidence that the Druids did use this particular unit, this stand of stones, as a temple, and had their mystic rites to take place at this Stonehenge monument. But that has, in the meantime, that has been fairly well discounted. And now we have come to think that this Stonehenge was, and here's where Dr. Cole and I were talking earlier, how can we get this, how do we get knowledge? Dr. Chismar, this whole problem of epistemological progress, how do we gain knowledge? Is it handed down to us from some spirit? Do we get it by, sometimes the French use the term bricolage, that you learn by doing. And how do we gain knowledge? This is the thing that I want to try to get across, at least as a starter, to introduce this whole program. Now there's fair evidence, and Gerald Hawkins, in this book that Dr. Cole is using, Gerald Hawkins has developed, he is the principal astronomer for Harvard University. And he spent at least 10 years studying this monument of Stonehenge. And you can show in some of the pictures that he has taken here that, I'm not sure that you can even get an idea here on this, but as the tall stones, which we said were the sarsen and the blue stones, there are regular places in the structure of this monument where these stones laid across like so, that at 4 times during the year, at the spring and fall equinox, and the summer and the winter solstice, the sun at high noon will be right in the center. Now, we have the ecliptic to take care of, so Hawkins definitely has calculated that out too. And Hawkins has shown that very likely this monument was a gigantic observatory, because from these stones you can tell exactly when spring, summer, winter, and fall are going to begin. And then surrounding this many-acre plot, there's a whole series of small stones called the Auber stones. There are 56 of them. And you can stand, when you go to that place, you can still see those 56 stones that make this circle. And he has shown that by starting with certain of these stones, you can predict the exact eclipses of the sun and the moon for a whole year. In fact, he has very positive evidence that this so-called Stonehenge monument is probably one of the first and very most accurate observatories that man ever had. Now, the whole book is filled with just unbelievable data that he has calculated out. And the whole point that I would make, and philosophically, we ask this question, how did they get this information? Was it pure chance? How intelligent were they? Well, we can't answer this question. Now, I believe it was Claude Lévi-Strauss, the French philosopher, who has argued that man was just as intelligent when he came out of the cave as he is today. He had the native intelligence in him, and that the only reason we know a little bit more today is that we've got the information that they've handed down to us from the past. But the interesting question to me, how in the world did they get started? So that's one of the great questions. And we still haven't answered it. We have no idea how this... Now, there are people who argue that intellectual people are beings from outer space, extraterrestrial beings, came in to the Salisbury Plain and gave these people the information. That's, take it or leave it. That's one of the things we try to figure out. But then another place, about the same time, if we have somewhere around 2000 BC, we can't be sure. We have another remarkable thing, and I've picked Egypt. Now, we don't have time to get into a lot of it, but we could go into Babylon, into Assyria, into Persia. All of these places had remarkable advances. But I've picked Egypt primarily because of the pyramids, because they're so, again, so hard to understand. Now, I've used primarily, in the material I've gathered, the secrets of the Great Pyramid, in case any of you are intrigued with this, and I'll pick out just 2 or 3 examples. And this is by Peter Tompkins. This is one of the best books from the standpoint of the early history of the pyramid, and it's devoted entirely to them. Now, in getting at that, I picked 2 or 3 things, and again, we wonder just what is it, and how did they get this information? For example, in this pyramid, and here's somewhat of a scale model of it, of the Great Pyramid. Now, I'll mention just 1 or 2 things. For example, if we take the base of it, put that in there. Should be able to do a little better than that. If we take the altitude of the Great Pyramid and compare that to the perimeter, the distance around, you get the value of pi. You remember in your plane geometry, the value of 2 pi r gives you the circumference of a circle. Now here, these people have built this pyramid, and they built it so exactly, and they carved it out of huge rocks that are piled one up on top of each other up to some 300 feet high. And these are so well put together that you can't even put a knife blade in between one stone and the next. They're so accurately drawn together. And this pyramid is so constructed that the altitude, as I say, to the perimeter, the distance around, gives the exact value of pi. Now, did they know? Were they aware of that, or was that just pure luck when they did that? Also, interestingly enough, if you take the altitude of this pyramid from base up to the altitude, and that perimeter, and multiply it by 10 to the ninth power, you get the distance from the Earth to the Sun. Now, how did they know, or did they know, that we are approximately 93 million miles from the Sun? How did they know that? Or was that sheer luck? We just haven't any idea. And then another thing that's interesting. If you take this face, the face of the pyramid, and calculate the area of it, the area of that face is to the altitude as 1. Well, actually, if you take the area, I'll put it this way. The area of the face to the pyramid height gives you the value of 5. The value of the golden mean. The Greeks worked long and hard on this. For example, if we take a line, let's say AB. In fact, maybe you worked on this in your plane geometry. But there's a certain place here, if we cut the point C, then AC will be to CB as CB is to AB as 1.619 is to 1. And that's called the golden mean. Now, you have to figure out where that is. And the Greeks worked long and hard to try to figure out how to determine the golden mean. And this is said to be the most perfect ratio there is. As an example, when Michelangelo carved the David, which is said to be one of the most exquisite statues ever carved, if this represents the height of his statue of the David, then the arms, which come down here, are such that this total height of the David statue is to the arm length, as you would just stand and let your arm hang down, as 1.619 is to 1. When they constructed the United Nations building, all of the angles in that building, as it's constructed, are in a ratio of 1.619 to 1. It's the most perfect architectural angle that there is. So now the question I would ask, so these things are very, very significant, but how did the Egyptians, how did they know all this? Was there some outside intelligence that brought it down to them? We're not sure. Now let me give you one or two other things. For example, in the structure of this pyramid, there's always an entrance to it. And this tunnel that comes down to the sarcophagus. Put that up here. When the Egyptians made this pyramid, it was primarily for burying. An important pharaoh was to be buried there. Now, when the king or the pharaoh was buried down in here, they knew that he was going to go on a celestial navigational trip. It was going to be an eternal trip. So they always put into this burial room all of the king's treasures. And in fact, that's been the source of the great treasures that we have in the various museums in many cases. Then this pharaoh, since he was going to be navigating, had to be able to tell where he was going. So when this pyramid was built, from the writings on the pyramid, on the stones, the hieroglyphics, it indicates that the pharaoh was buried so that he would be able to look out of that tunnel and see a guiding star. So he would, you people, any of you have done navigating in sailboats and so on, know that you have to have a navigational star. Now, today, we use Polaris, which we call the North Star. But we also know, if you've studied some geometry, or some astronomy, you know that the Earth wobbles on its axis. That this is the north-south axis. We know that through a period of some 26,000 years, we will make one complete turn on the ecliptic. In other words, the thing will tend to wobble. I don't have a meter stick here, but the axis of the Earth will wobble like this. So right now, if we're out navigating, we do our navigation in terms of this North Star Polaris. For example, we do know from astronomy that in 13,000 years from now, if any of us are navigating, we will use the star Vega as a North Star, a guiding star. Then there is another star that falls on this ecliptic, and it's the star Alpha Centauri. Now, if you go into the Great Pyramid today and check up the site on this, you don't see Polaris through that now. You don't see any star. Looking up here today, there's no guiding star. But we can say this: well, at one time, when that pyramid was built, it probably saw Polaris, and Polaris has moved past. And the star Alpha Centauri is coming into being, and you can calculate from that ecliptic and the number of angles of arc that has passed, how long ago that pyramid was built. And they used astronomy to calculate it, and they figured that the Great Pyramid probably was built maybe 3,500 years ago, or well, even more, about 4,000 years ago. Or it was built at about 2000 BC, which is about the same age as Stonehenge. Then you might say, well, how can we be sure of that ecliptic? Will that give us the true value? Or is that the reason that they had this tunnel built in that fashion? Well, they've found that if they take some of the wood from the burial chamber and use what we call carbon dating, measure the amount of carbon-14 in it, they get approximately the same age as you get from the ecliptic, which gives us a pretty good idea when that pyramid was built. All of these things then become, to me at least, very interesting things, making us wonder, how did they gain all of this knowledge from that source? Well, now, for example, in this king's chamber, in the burial chamber, and of course here's the tunnel that goes up to the outside of the pyramid. In other words, it'd be like you'd go down in here. If you take the distance of the pyramid, the length of that, of the burial chamber, and divide it in half, just cut that down so this distance right here is 1/2, and this is 1/2. Then use this to swing a line, swing an arc. And swing that line down here. It'll come down and cut this total distance, strangely enough, such that this value right here, that we've measured right here, is 1.619 units of the whole length of that burial chamber. In other words, this thing is constructed so that it gives the golden mean. And the question immediately comes, how did they know this? How did they get the information? And we could talk and talk and talk for a whole semester just on that point, on man's gaining of knowledge. Now those things, let me put it this way, those things, folks, are pretty well established, and I think we would accept those. Now let me toss one or two things into the hopper and see what you think of this. When they built the pyramid, king's chamber is down here. As I say, you go into it from this tunnel. And it comes right down. Now this is a little model such that this theoretically would represent the king's chamber. And the center of that is right under the apex of this triangle, of this pyramid. Now, this story goes, and Tompkins pays a lot of attention to it in the last part of his book. Now, he merely hands out this material. You can take it or leave it, it's however you want. He says this, that as they began to study the Great Pyramid, and this first study was done by a physicist from the University of California, Dr. R.T. Alvarez, who is a Nobel Prize winner. So he tries to lend some credence to this. They said this, that when they went in here, the first time they noticed it, you have to go down this tunnel, get down into this chamber. And they went down in there and they were working, and then they left. They went back to their respective communities, took some of their materials with them. But they came back a year later, and they made two discoveries. They found that when they left about half a gallon of milk, of fresh milk. They didn't mean to leave it there, but somebody overlooked it. When they went back a year later, they found the milk, and it was just as sweet as when they left. In other words, it had preserved quality of the milk. Then, now here's something else that stretches your imagination. One of the persons in there at the time had inadvertently dropped a couple of straight razor blades. They had been used. They were pretty badly nicked up. When they found the razor blades a year later, they were as sharp as you would get in a new blade. They had regenerated themselves. Now, can you believe that? That's pretty tough to take. But you know, folks, now here, Dr. Cole and I were talking about this just before he came in. See, now the first things that I told you can be authenticated. I would say they're scientifically sound. But what about these other things? For example, this has developed, this has led to, and if you haven't been aware of it, watch for it. Because these things right here, which seem pretty doggone ridiculous, have led to a very substantial number of people involved in a pyramid cult. And you can buy, now this was made, this is supposedly a dimensionally scaled model of the Great Pyramid. And the reason this was sold was to try some of these experiments. In other words, now they say you can get it too small, and I think this one is. I've had students in the past try this out. They argue that if you move this thing and put a razor blade right here, a dull razor blade, close that, and then set it out. Now it has to be set, when you set it out, it has to be, this side has to be absolutely north and south. Now if it's off just a little bit, you're going to have some trouble. But you let that razor blade in there for a few months and it'll sharpen itself. In the meantime, you need a shave very badly if you're going to count on that razor blade. But then they said if you put seeds, now there have been people who claim, they've made scale models of these of the order of the size of this, the height of this room. And they claim, for example, that if you go into such a scale model and sit in there, it'll rejuvenate you. If you're tired and worn out, sit in there, but you have to be right under the peak of this pyramid. And they claim, for example, that if you put moist seeds and put them right at this spot, they would germinate much faster than if they're just out here in the room. Now, the interesting thing is, I've had students try with that one and had no luck whatsoever. Gave up and brought it back to me. But they sell thousands of these scale models of these pyramids, and they've developed quite a cult. almost a religious cult, if you will, over the therapeutic and impossible situation in the pyramid. So you always have extremes. And yet, Tompkins goes into a great amount of that in this book. Well, I mentioned those things primarily because they're interesting, I think, in that they ask the question, how do we gain knowledge? And how valuable and how much can we trust the knowledge? Now, some of the things are quite valid. Then there are other things that we're not sure of. But you know, as this developed, folks, then coming into the picture, we find a little later on, in the neighborhood of, Homer wrote the Iliad and the Odyssey, about 600 BC, something like that. The Greeks begin to come into the picture, and I'm going to hypothetically say around 600 BC. They were there before the Achaeans and whatnot. But then the Greek culture begins to develop, and certainly we people here in the Western culture, we owe a tremendous amount to the Greeks. And and I can only pick a few. And I may not be able to cover it all right here, but I wanted to get at some of them. For example, one that I think we should take up would be Pythagoras. Pythagoras, and you've taken plane geometry, and you all had fun with the Pythagorean theorem. Now, the point again that I'd want to get across is that each one of these people, of these Greeks, and we have a whole bunch of them, Thales, Heraclitus, Parmenides, Anaximander, Zeno, Plato, Aristotle. Now, I'm certainly not covering all of them by any means, but these are some that come to my mind as ones who had played a very important part in getting our Western culture started. Now, Pythagoras was one of them. Now, the reason I picked Pythagoras is that and I want to mention this, that in each of these cases, they were interested in gaining knowledge. And basically, the term science literally means to know. We want to know the how, the what, and the why if we can. And each of these people not only were mathematicians and scientists, if you will, but they were philosophers. They were wondering about the meaning of life, the purpose. How do we gain knowledge? What is life? What is it like? Are there any fundamental particles? And in that respect, we'd have to put in Democritus, who was one of the first academicians that we would encounter. Well, now, Pythagoras, I'll start with him. Pythagoras believed that if you will, things could be reduced to whole numbers. Now, he didn't concentrate his whole life on the Pythagorean theorem by any means, but nevertheless, he was philosophical, and he felt that there was meaning and purpose, significance to the whole life process, and that we tried to gain knowledge by doing it. Now, my question would be this: how did Pythagoras come up with the idea? Let's say that if this is one side, this side here, what made it possible? How did he get this information that a squared plus b squared equals c squared? That the square on these two sides would equal the square on the hypotenuse. How did he gain that information? Did somebody tell him? Did he get up some Monday morning and say, I think I'll develop the Pythagorean theorem today? We had the slightest idea. But what made it possible for him to come up with this? Now, I've taken this, let's see if I can make it work here, from Bronowski. Bronowski says, he died a couple of years ago. Bronowski was the very outstanding philosopher, mathematician, who was out He came from Germany and spent most of his years in La Jolla, California. Gronowski asks this. He says, do you suppose we might have done this? Now here's our right triangle. Here's the hypotenuse and the square. Now he says, do you suppose that we might have gotten this thing I'll try to build the hypotenuse first. And this is a piece in here. Now now you can see what I've done there, rather poorly, is to take the hypotenuse of the triangle and create the square. Now, do you suppose that as he worked with this, that he might have done this? He might have said, well, look, if I put these together, I've used all the material. Now, I don't have a ruler here, but I'll just hold this up right here. If I hold this card right here, now I've got the square. I've got the square that belongs to the long side. Then here, I have the square that if I measure it is exactly equal to the square that I would build on the short side. So literally, by just pure messing around, if you will, I've used the same amount of material to show that the square on the long side plus the square on the short side is equal to the square that I had built on the hypotenuse. Now, I don't imagine that you studied it that way in your geometry class, but the point would be this. How did we learn that? How did Pythagoras come across this? Now, the story goes, first of all, Pythagoras wanted to reduce everything to unit value, 1, 2, 3, and so on. And so the story goes that one of his pupils came to him one time, and we don't know whether this is true or just some wag making it up, but the pupil came to him and said, Master, I've got a real problem here. Now, Pythagoras said everything can be reduced down to whole numbers, a monism, if you will. And the pupil said, look, teacher, I found this, that if I make my right triangle, 1 squared plus 1 squared should be equal to the square on the hypotenuse. Well, the square root of 2 is 1.414, and so on. In other words, you're telling us that everything can be reduced down to unit values, to unit numbers. But here's a triangle that isn't a whole number. And Pythagoras says, well, that's a shock. Don't let anybody find out about it. That's the way we'll keep that under control.